This is Kaappi, a complete R7RS scheme written in Zig. In the next few minutes, we'll open the interactive prompt, evaluate some expressions, write a program in a file, and then turn that file into a native binary you can run on its own. Installing it is one line, and it's in the description below. Let's assume you've done that and get straight to the interesting part. Run Kaappi with no arguments, and you get a prompt. Type an expression, press enter, and it evaluates it. 2 plus 3 is 5, 6 times 7 is 42. The operator comes first, inside the parentheses. That's the whole syntax, and we'll come back to it properly next episode. The underscore is a small convenience. It holds whatever the last result was. 42 times 20 is 840. And then, underscore plus 160 gets us to around 1,000. Handy when you're exploring and don't want to name everything. Anything starting with a comma is a command to the REPL itself, rather than scheme to evaluate. Comma help lists them, loading a file, importing a library, breakpoints, garbage collection stats, and comma quit is how you leave. Worth a look early, it saves you guessing. The traditional first program. Display prints a value, and newline moves to the next line. Scheme keeps those separate, rather than bundling them together. The REPL is for exploring. Real programs live in files. Same to expressions, saved as hello.scm, and you run the file by handing it to Kaappi. No build step, no project scaffolding, just run it. And here's the part that surprises people. Kaappi compile sends your program through LLVM and produces a native executable. Run it directly. No Kaappi in front, and there's our greeting. Ask the system what it is, and it's a genuine native binary for this machine. Scheme compiled to the metal in under a second. That's the tour. An interactive prompt for exploring, files for real programs, and a compiler when you want to ship one. Next episode, we slow down and learn the language itself, the whole of Scheme in about 10 minutes. Thanks for watching. Subscribe for more Kaappi.